Hello everybody and welcome back. In the previous video, we have seen how to connect 4 external LEDs to our Raspberry Pi Pico and how to blink it using this code that we have written. And we also said that this code may not be very efficient because if you want to connect more number of LEDs, then repeating these lines may not be the most efficient way of coding. So in this video, we will see how to blink 4 external LEDs using arrays and loops. So we will make use of arrays and loops and see how we can achieve that same blinking. So let's see how we can modify the code for that. So the connection stays as it is, there are no changes. So we'll just make modification on the code. So here I have the code using arrays and loops. So let me explain it line by line. First of all, I am declaring a constant integer called num_LEDs, which is equal to 4. That means we are declaring a constant called num_LEDs, which represents the number of LEDs that we are going to use. Now, why we are doing this is because in the future, if you want to add more LEDs, you can just modify the number over here. Next, I am declaring a constant integer array called GPIO_pins. And in the array, I am putting the values 0, 1, 2, 3. Now, what are these? These are the pin numbers that we are going to use. So this array is nothing but the pin numbers that we are going to use on the Raspberry Pi Pico, or the pin numbers on to which the LEDs are connected. Okay, so the array holds everything. So even if you want to add more pins in the future, you can just add the pin numbers to this array. Next, I am declaring another constant called blink rate, which is equal to 500. Now this blink rate is actually the delay that we are going to have for our program. In the previous program, we saw that we were using a delay of 500 milliseconds. So we will repeat the same here. We will use 500 milliseconds. And if you want to change the delay, you can just change it over here. And if you make that one change here, it would reflect in the whole code. So we can see that this is really a flexible and scalable code. Next, I am declaring a static boolean called flag, which is equal to 1. Now this flag can toggle between 0 and 1. That is why it is declared as a boolean, and it is a static kind of a variable. So we will see what is the use of this flag as we move ahead in this code. Okay, now coming to the setup function, we know that in the setup function, we were actually initializing the pins. We were setting each of the pins that we are using as an output. So we are going to do the same using loop now. So here you can see that I'm using a for loop which says int LED equal to 0. So the for loop is going to use this variable called LED for running through the loop, and it is initialized to 0. The condition that we use is LED less than num LEDs and LED plus plus. So this loop would run until and unless LED becomes less than the num LEDs. What is num LEDs? Num LEDs is the number of LEDs that we are using, and in this case it is equal to 4. And then this is the increment LED plus plus. And within the loop we write only one line of code, and that is pin mode GPIO pin of LED comma output. Now what this does is it checks the array GPIO pins. So here we have GPIO pins, and LED is the variable that we use for iterating through the loop. So this LED would run from 0 until 1 less than the num LEDs. So it will go from 0, 1, 2, 3. So GPIO pin of 0. What is GPIO pin of 0? GPIO pin of 0 is 0. That is the first LED. And in the next iteration of the loop, this LED would become 1. So it would be GPIO pin of 1, which is equal to the second LED here. And then in the third iteration, this would become 2. So that will be equal to the third LED here. And then it will be equal to 3, which is going to be the fourth LED here. So we are representing the LEDs using the arrays, and each of them is set as an output. So we see that using this one line of code, we are able to initialize all the LEDs that we are using here. So in the previous code, we were writing this line 4 times. So here with the help of the loop, we are efficiently able to minimize the number of lines. And even if you want to add more LEDs in the future, you just need to modify the number of LEDs here and put the pin number to which it is connected into this array, and you don't have to modify this setup function anymore. So we see that this is quite an efficient way of writing the code. Okay, now coming to the loop function, here we are again running a loop from 0 to num LEDs. And inside the loop, we are calling a function called control LEDs, to which we are passing the variable LED and flag. Now this control LED is a user-defined function, that is a function that I have written, and we will see what this function does as we go below. Now let's see what does this function pass. It passes LED. So LED, it goes from 0 to 1 less than num LEDs. So it is going to go from 0, 1, 2, 3. So 0, 1, 2, 3 will be passed here at each iteration, and flag will be passed. What is flag? We initially set flag equal to 1. So 1 will be passed. So let's see that what will happen when the first iteration runs here. So 0, LED equal to 0. So 0 here, and flag equal to 1. So flag equal to 1 means this 1 will be passed here. So 0 and 1 would be passed to control LEDs. So let's go to this control LEDs function, which is this. So in control LEDs, what we are doing is, it is a function which has return type void, and it has two parameters. One is LED, which is of the type integer, and another one is state, which is of the type boolean. So when we called it over here, it first passed 0, which is equal to the LED, and then the flag was 1 because flag is set to 1 over here initially. So 1 will come to the state. So LED is equal to 0, state is equal to 1. Now it says if state is equal to 1, then digital write GPIO pin of LED high. That means if the state is equal to high, that means if the flag that we passed here was equal to 1, then that particular GPIO pin, so LED is 0, so that LED number 0 will be set to high. Okay, it is not LED number 0, it is the 0th LED in our array index. Okay, that will be set to high. And then in the else part, it says digital write GPIO pin of LED low. That means set that LED to low. So here, since our state is equal to 1, it is not going to come to the else part. It is just going to set that particular LED to high. That means it will turn it on. And then it is going to come back to where it was called. So this function was called over here. So it comes back to this place. And then what happens? This loop is going to run again. Means the next iteration of the loop would run. So LED will now become 1. So we are going to deal with the second LED in our array. So here LED is equal to 1 and flag is still equal to 1. So LED 1 would be passed here and state is equal to 1. So if state is equal to 1, what should we do? That particular LED should be turned on. So this loop would run for all the LEDs, and for all the LEDs, this function would be called, and state was always equal to 1. So all the LEDs would be set to high. That means all the LEDs would turn on. Okay, now what happens at the last iteration of the loop, when this condition will become false, then what will happen? We will break from the loop and then we will come to this part, which is delay blink rate. So delay blink rate means, what is blink rate? Blink rate was equal to 500. So it will give a delay of 500 milliseconds here. And then we say flag equal to negation of flag. So whatever was flag, the negation of that will be taken. Remember that flag is a Boolean variable. So flag was equal to 1 if you remember, and negation of flag means it will become 0 now. So now flag becomes 0. And then what happens? Remember that this whole thing is inside the loop function. So since it is inside the loop function, this complete thing would run again from the beginning. So when it runs again from the beginning, what will happen? It will come to this loop again, and this loop will again run from 0 until num LEDs, and it is going to call the control LEDs function, and each of the LED numbers would be passed here from this loop. And now remember that flag is equal to 0. So we had set flag equal to negation of flag, and because of that, flag is now equal to 0. So each time this control LED is called, the LED number would be passed and flag will now be 0. So when it comes to this control LEDs function, what happens here is that it is going to pass the LED number here, and state will now be equal to 0 because flag is 0. And it will come to the if condition. If state equal to 1, no, condition is false because state is equal to 0 now. So it will come to the else part, and then it will say digital write GPIO pin of LED low. That means that particular LED will now be set to low. Okay. So since flag is always going to remain 0 for this iteration of the loop function, so every time this control LED is called, that particular LED will be set to low now. And once the loop completes and once the condition becomes false, then what happens? We will break from the loop and again we will come to this line number 18 where we will give a delay of blink rate which is 500 milliseconds. So again there will be a delay of 500 milliseconds and then we say flag equal to negation of flag. So the flag which was now 0 will again toggle and become 1. So flag now becomes 1 again. And this loop will again run because this is in the loop function. So at that time when it runs, flag is now equal to 1. So what happens when this function is called? It is going to come to this if condition where state is equal to 1 will be true and the LEDs will be turned on. So what essentially happens is that with each iteration, we are turning all the LEDs on, giving a delay of 500 milliseconds. Then when the flag is set to the opposite or 0, then what will happen? It will again call this function where all the LEDs will now be set to low or all of them will turn off. And this loop continues or it runs repeatedly again and again. So all the LEDs are going to turn on and it is going to have a delay of 500 milliseconds and they will all turn off again with a delay of 500 milliseconds and hence we will be able to achieve the blinking. So let's run this and see if it is working as expected. So let me start the simulation here. So you can see all the LEDs are blinking with a delay of 500 milliseconds. We achieved the same result that was achieved in the previous code. So the good thing about this code is that this is a really flexible and scalable code. If you want to add more LEDs, you just need to modify the connection here to add more LEDs and just mention the number of LEDs here and just put the pin number to which the LEDs are connected into this array, and that's all you have to do. This code is going to work for any number of LEDs. You don't have to change anything below in this code. So that's how we write an efficient code for blinking 4 external LEDs connected to the Raspberry Pi Pico. So with that, I also hope that you have understood how to make use of arrays and also how to make use of loops in this Raspberry Pi Pico coding using Wokwi. So this is the same even if you do it on the hardware, you can use this same code and it would work just fine. So just make sure that you are connecting everything correctly and you mention the pin numbers correctly in the code to which the LEDs are connected. So if you have a little bit idea about C programming, you can apply the topics that you have studied in C programming like arrays, loops, and even other things, even in this Raspberry Pi Pico programming, because here we are programming it using C language. So I hope this was clear to you. We will take more examples and see even more interesting things as we move ahead. So I hope this was clear to you. Thank you for watching and see you in the next one.